In this video we are going to study about continuity at a point, and here there is a mathematical definition part. At the point x0, if there is limit exists, and if the function has value there and these values are equal to each other, when they are equal to each other, limit value and the function value, if they are equal to each other, then function is continuous. At that point we will say. Here there are three examples for it on the graph, and when it is graph it is more easier than the formula, because when you see the graph you can easily understand the function is continuous or not. The first two cases, they are not continuous. The third one is continuous. I'm going to explain here. Now when you check the limit of the question, when you approximate to this one here, to this one, as you see the limit doesn't exist, because left-sided limit and right-sided limit, they are not equal to each other. That's why the function has no limit. If it has no limit, it means that we cannot talk about the equality of the function value. The function value here, it's also different, as you see, so it means that we don't have a limit for this point. Here the left-sided limit and right-sided limit is same, but the function value at the point C, here let me show this part. Limit extends to C from the positive side, it's equal to L fx, and limit extends to C from the negative side, fx is equal to L again, L. Left-sided limit and right-sided limit, they are equal to each other. So when you check this case, left-sided limit here and the right-sided limit, they are coming to same point, which is equal to L. But the function value here, when you check the function value, this red point is showing the function value, which is fc. And we are checking that for that one, and fc, as you see, this point is not equal to L. That's why at this point function is not continuous, or if it is not continuous, we have to say it is discontinuous for this part. And here this one is also discontinuous. Is going to be okay. The third one is continuous, because the limit here, left-sided limit, right-sided limit, and the point, as you see, they are all equal to L. That's why they are continuous. And there's a second way to understand that one without checking the limit or not. There's an easy way to understand the function is continuous or not. When you shift your hand from left to right, if you when you draw the graph, if you shift your hand, if you shift your hand, it means that function is not continuous. As you see here, when I move my hand from left, when I draw the graph on the graph, when I move my hand from left to right, when I'm coming, as you see, I didn't shift my hand. Here I have to shift. I am coming here, I'm coming like this, and I have to stop here because the function is not continuous here. Then I have to continue from the other part, and I'm going like this. Okay, that's why these two functions, they are not continuous, and the third one is continuous also. Okay, now the first exercise is graph exercise. And as I said, on the graph it's very easy to understand. When I move my hand from left to right, when I draw on the graph, if the function is, if I am not shifting my hand, it means that function is continuous. So for -3, the function is continuous. At x is equal to -3, function is continuous. Okay, when I come to -1, you see I'm moving my hand and I have to stop here. There is a point here, white hole here, and I have to stop here, and then I'm continuing again. So I shift my hand That's why we cannot say it is continuous. So at x is equal to -1, function is discontinuous. Okay, at x is equal to 2, at x is equal to 2, function is at x is equal to 2, as you see here. I shift my hand, I jumped actually here, and I continue from the other side, and this continues. And at x is equal to 4, function is discontinuous again, because when you come here it was like the at x is equal to -1, you are coming here, but there's a hole here. That's why you have to shift your hand, and you should have to start from other side. That's why function is discontinuous at this point. Now I'm going to explain, without using the graph, how to understand the function is continuous or not at the point x is equal to 1. Okay, limit x tends to 1, fx is equal to what? I have to find. For that one, limit x tends to 1 from the positive side, fx is equal to what? I have to find. And limit x tends to 1 from the negative side. What is fx? I have to find firstly. Then I'm going to find, with respect to these two, I'm going to find the limit value, and if they are equal to each other, limit exists, and we are going to find the limit value. Then we are going to check the function value there. Okay. Now limit x tends to 1 plus means 1 plus v means which is greater than 1. So when it is greater than 1, I have to use this function. So it's going to be equal to limit x tends to 1 from the positive side, which is greater than 1, minus x plus 3. For the numbers greater than 1, we have to use this function. Okay, then this is polynomial function. Positiveness or negativeness is not important for the polynomial functions. Directly you may replace the number what is written here in polynomial functions. So it's going to be -1 plus 3. I replaced the -1. I replaced by 1, but the minus x we have, that's why it becomes -1. Then the answer is going to be equal to -1 plus 3, 2. And limit x tends to 1 from the positive side, this time negative side. 1 negative means which is less than 1. That's why when the function is less than 1, it means that it should be the first function, which is x squared plus 1. Here, x squared plus 1 I'm going to replace by, and when the function is polynomial function, directly you may replace by this value, and it's going to be equal to 1 squared plus 1, which is equal to 2. And limit x tends to 1, fx, it should be equal to 2, because I checked left side limit and right side limit. They are equal to both 2, and the limit value is going to be equal to 2 there. Limit exists, and the limit value is 2. Okay, the last one. Fx is equal to what here? F2 here, when x is equal to 2, fx is equal to, it should be when x is equal to, I made a mistake about the value. When x is equal to 1, f1 is equal to what I have to find here. When x is equal to 1, here, as you see on the function, when x is equal to 1, use this function. Fx is equal to 2x, it's going to be. So f1 is equal to 2 times 1, it should be, and f1 is equal to 2. And here the c value, limit x tends to c, fx and fc, they have same value, which is equal to 2. Since this 2 value is equal to each other, limit x tends to 1, fx is equal to f1, which is equal to 2 is equal to 2. Then the limit value, they are equal to each other. So function function is continuous at x is equal to 1 is going to be. Okay, for this question, the function is continuous at this point, and they are asking to find the a and b value. So it means that limit x tends to 3 from the positive side, fx must be equal to limit x tends to 3 from the negative side, fx, and this value should be equal to f3. Okay, when I say 3 from positive side, which is greater than 3, I have to use this function, 3 negative, this function. Limit x tends to 3 from the positive side. It's equal to 2 times 2ax plus 4 it's going to be, and limit x tends to 3 from the negative side, fx is going to be equal to bx plus a, and here f3 it should be equal to, for this one the function, it should be equal to fx function, it should be equal to x minus 5, and when I replace by 3, 2 times a times 3, because it's polynomial function, plus 4, it should be equal to b times 3 plus a, and here the x value is equal to 3, so 3 minus 5 it should be. Okay, 2a plus 6a plus 4 is equal to 3b plus a is equal to minus 2. Here we have 2 unknown, here we have 1 unknown, so it's easy to solve this 2 here, which means 6a plus 4 is equal to minus 2, 6a is equal to minus 2 minus 4, 6a is equal to minus 6, a is equal to minus 1 is going to be 6a over 6, which is equal to minus 1, it should be. Okay, the second one, I found the a value and I have to find the b value here. B is equal to 3b plus a. We know that's equal to 3b plus a is equal to minus 2 also. And we found a is equal to minus 1. 3b is equal 3b plus a is equal to minus 2. 3b minus 1, I have written 2 times here, I lost my concentration this way, plus minus 1 is equal to minus 2, 3b is equal to minus 2 plus 1, and 3b is equal to minus 1, b is equal to minus 1 over 3 is going to be for this question.